the way that we've done the next session is really as an example of a startup called Contoso Air that is basically born in the cloud. They're going to be adopting Kubernetes. They don't know a lot about Kubernetes, and really this is going to be an accelerated journey in terms of them going from zero to hero, basically. So the types of things that they're going to be concerned about as they're maturing from their Kubernetes adoption, some of the challenges that they may come up against, as well as the features within AKS and how they're actually going to be able to help them. So I'm going to hand over to Ahmed, who's going to kick this one off.
Hey everyone, I'm Ahmed. I'm a product manager on the AKS team as well. So yeah, as Justin mentioned, we'll be going and exploring through a journey of a startup called Contoso Air, which is an airline that is looking to standardize on Kubernetes and containers. And along the way, they'd also like to modernize their applications to leverage new functionality, such as AI, which everyone is trying to get to these days. So what we'll be doing is we'll be going through a maturity journey with that customer, where they will start with few to no knowledge of Kubernetes and progress as they grow in their engineering and ops teams. And as they mature, we will guide them through how they can secure their platform and how can they build in architecture and operational best practices to finally standardize their entire operations on Kubernetes. So with that, we'll be starting from source code. So they have the application, it's written in their, they've written before, and they want to see what's the easiest way that they can get this deployed to Kubernetes. And essentially, when you're just getting started, you want to go quick, you want to be able to deploy things fast, but you also want to make sure that you're on a path that will help you, set you up for success. And we have a feature called automated deployments that builds on an open source code generation engine called Draft, which generates Kubernetes manifests, it generates Docker files from simple parameters. And those generated manifests, they include the best practices that developers will eventually need to do from day one. Things like having topology spread constraints on their deployments, things like liveness probes and hardened security contexts. Automated deployments can connect to source control repositories hosted on GitHub. And also today, we'll be adding Azure DevOps repository support. And whether they have a Docker file already, whether they have a bunch of manifests, both of them or none of them, automated deployments can help take all of that and deploy it with a pipeline, with a CI/CD pipeline. And beyond the initial generation, continuously following Kubernetes workload security and best practices hasn't been any easier. With the integration with Azure Policy, which we'll talk about later in the session, we have a feature called deployment safeguards, which essentially enforce security best practices right when you're starting to deploy things to your cluster. It can operate in a warnings mode, which is good for when you're just getting started, you're not really sure what's going on. But eventually you can also switch it to enforce mode, which will block deployments when necessary, but also it can modify deployments so that you can force it to adhere to best practices. And talking about the ease of use, the easiest way to deploy apps on a cluster is on AKS Automatic. So AKS Automatic offers an experience that is making most common tasks on Kubernetes fast and frictionless, but also preserving the flexibility and extensibility that comes with Kubernetes. And Azure takes care of the cluster setup, including node management, scaling, and security best practices that are pre-configured to follow well-architectured recommendations. And these clusters automatically scale, of course, based on workload requirements, and they are really tuned for running production apps. So with that, I'd like to switch to a demo of how you can get started with deploying apps to AKS Automatic. So to start, their application is composed of a couple of services. It's written in Node.js, and they already have a Docker file for it, so they don't need to generate one. And what they'll do is they'll go to the portal, they go to an AKS automatic cluster that's already created before. They'll head over to the automated deployment section, and they can then connect that to their repository, either GitHub or Azure DevOps. In this case, it's hosted on GitHub. So what they'll do is they will pick that repository after authenticating their account, and they'll now be able to configure how they'd like to deploy it. So in this case, they have an existing Docker file, but they can also automatically generate one based on the application. So what we'll do here is we'll pick the Docker file from the repository. And if they didn't have an Azure Container Registry, we can create them one. But in this case, they already have one that's connected to the cluster. And they will specify what container image name they want to use. They can use an existing set of Kubernetes manifests, or they can generate a set as well, which really makes things easy to get started with. So their application is hosted to run on port 3000, and they're going to create a new namespace to get this application deployed to. And now comes a more interesting part, which is, what do they want to set up? So their application is set up for automated automatic scaling, and they want to expose it on a public ingress. They have an SSL certificate for it, which is already uploaded to the Key Vault, so they'll pick that from their Key Vault. And their domain name is also hosted on Azure DNS, so they'll be able to pick that as well to really get the application published. So they'll publish this at air.demo. A long domain name that I just created here. And yeah, a bunch of files will be generated now. So what's going to happen now is that automated deployments is going to create the namespace on the cluster. It's going to set up a federated identity credentials between GitHub Actions and the cluster. It's going to create a pipeline on GitHub. And all of this is actually going to go through a pull request. So it's going to open a pull request on the repository, which shows all of the created files here. So you have the pipeline itself, you have a deployment with the set of best practices in there. So you have resource limits, resource requests and limits already there. You have liveness probes, you have security capabilities and the security context set. And you have an ingress created, which loads up the certificates as well from Key Vault. So all this looks good. So I'll merge the pull request, which will now kick off the GitHub Actions pipeline to get this application built and pushed to the Azure Container Registry. So fast forward a couple of minutes. And the image is built, and then it's deployed to the cluster. And now they'll go back to the portal and see what's been deployed there. So they'll head over to the services and ingress tabs so that they can open up and check out that application in their browser. So in a second here, yeah, we have the application, and the DNS zone has been configured, and it's loading up with an SSL certificate. Yeah, so the app is running. They can search stuff. They can search for flights. But at this point, they'd like to make it a bit smarter as well. And you'll see here that there's a Inspire button that's sort of disabled here. So we want to make that part work. So usually, and Ralph showed this earlier in the session, workload identity is the way we want customers to use or to authenticate applications to use Azure services. We don't want to use secrets and API keys and all these sort of things anymore. But setting up workload identity is a bit tedious. you have to create identities, you have to create service accounts and federated identity credentials and put all of this thing together. So we have a feature called Service Connector, and Service Connector really streamlines all of this operation. It creates the workload identity configuration, it sets them up with your deployment. It can even configure firewall settings on the target services that you're using, so that if you're using like a private AKS cluster with a private database, connections can happen over the internal network. And there's over 30 services supported now. So what they'll do here is they want to add Azure OpenAI into that application. So going back to the cluster, they'll head over to the Service Connector tab, and they're going to create a new connection. That connection is going to be living in the namespace where they deployed the application. So it's Contoso Air, and they'll pick up OpenAI as a service. They already have an OpenAI deployment in their cluster, in their subscription. And using workload identity, they can select a managed identity in Azure to assign those permissions to. It's going to set the role assignment on that identity. It's going to create that to be used in the app. In a couple of minutes, once they hit create, all of this is going to happen in the background, and then they have a connection that's created. And now it's time to inject those parameters into their application. So they can get an example YAML snippet to use, but they can also target an existing deployment that they have in the cluster, which they have here in the app. And Service Connector would change and modify that to include the tags needed or the labels needed to have workload identity work. It will inject the service account that it will create. And in a minute, that app will now have the ability to talk to OpenAI. And what this is doing, it's essentially using the OpenAI embeddings API to generate recommendations based on what we have in the database. Yeah, cycling and Amsterdam go together. So I have to admit something. Like when I was coming here, I was thinking to myself, okay, could I actually code this entire demo on the flight? And I actually did. So, but I couldn't do it without some help, of course. And for that, coming back to the integrations with developer tooling, I used the GitHub Copilot agent mode with VS Code. Have any of you tried this before or tested it out? 3-4 people. I really want you to go and try it out. It's really cool, actually. Throughout the flight, I had some Wi-Fi, kept iterating over it, and eventually got something up and running. And this also is made possible with some of the integrations we have to make it easy to get from Visual Studio Code, from where you're doing your coding, and integrating with AKS. So we're trying to simplify different tasks you might want to do on a cluster. So we also have an AKS extension in VS Code that can help you do common tasks like view the deployments, restart deployments, check logs, and so forth from things that are in your cluster already. But also we have the GitHub Copilot for Azure integrated within VS Code as well, with support for Kubernetes, and can help you generate Kubernetes commands and deploy manifests and a bunch of these things. So if developer experiences and developing and coding excites you, so I'd like you to join us later in the event. If you're heading over to KubeCon, we'll be doing a bunch of this, as well as getting a sneak peek into a new feature we're doing on prototyping with AI directly in the Azure portal. We'll be doing that in a demo in the booth. And with that, I'd like to hand it over to Pavneet, I think.
Is it you? Fine. No.
Yeah, so take us through the day 2 journey of what they can do after that.
Thanks, Ahmed. Well, I didn't code a demo on the flight. I don't know how I'm going to beat that, but I did build this deck on the flight, so I'll present that instead. So now that the developer team has actually hit production and they're starting to grow and mature, they're looking to kind of nail down and mature their day 1 and day 2 ops, right? From observability to application autoscaling to cluster autoscaling, and setting up a secure integrations with other Azure services through Service Connector that he demoed, but also looking at some of the more advanced features for more control as well. So first up, let's start at the beginning, right? The control plane. AKS provides users with a highly scalable, reliable control plane up to the upstream Kubernetes limits, right? Control plane in AKS is already zone resilient. That means we spread your API server, etcd, etc. across multiple zones. And it comes with an uptime SLA. So you have a guarantee, a financially backed guarantee that if your API server is not working or is not responsive, you get your money back. And then AKS automatically scales your control plane based on the load in your cluster. For example, how many nodes are running in your cluster, or how much load is being passed through to API server. We look at those signals and actually auto-scale your control plane. Now, that's great, but things still go wrong. I want monitoring. I want troubleshooting, right? And in Azure Portal, you have this feature called Diagnose and Solve Blade, right? And honestly, to me, it's one of the most underrated features in AKS. It should be the first place where you start your triaging when something goes wrong. Why do I say that? Well, first of all, it's free. Even if all your monitoring was disabled, that feature would still work. It's out of the box. You don't need to configure anything. And then it covers a variety of data signals, including our own internal service logs. So when we detect something is wrong, we've set up detectors to actually flag that to you with the troubleshooting guidance in Diagnose and Solve. So we're not just using the signals in your cluster, we're using our service signals as well. Now, Ahmed showed with AKS Automatic, you get a lot of the defaults kind of built in and best practices built in, right? And that's true for monitoring as well. And our recommended monitoring stack is actually the Azure Monitor stack. You have log analytics, which is your single logs destination. While for metrics, we support Azure Monitor metrics for Managed Prometheus as our recommended solution. But really, our goal is to meet where the customers are, right? So we contribute a lot to upstream open source solutions like Retina, which powers ACNS for network observability, to Hotel for application monitoring, Prometheus and Grafana for your metrics, storage, and visualization. So, that's where the open source standards are, and that's where we want to be as well. And today, most of AKS customers actually love Prometheus, right? And on AKS and in Azure, because Azure provides a managed Prometheus solution, we see a lot of customers using it to reduce their operational overhead so that they don't have to run a managed Prometheus instance and then kind of configure that and set up the end-to-end pipeline. The added benefit of Azure Managed Prometheus is it natively integrates with multiple AKS add-ons and extensions, right? So it's really become the one-stop shop for your metrics. For example, Azure Container Storage, recently we did preview of Azure Container Storage integration with Managed Prometheus, where you can now monitor your storage pool metrics from Managed Prometheus. Your control plane metrics, your managed infrastructure, all of those metrics are integrated with Managed Prometheus. And we do tend to be conservative on the default scraping rules because we want to be conscious of, these metrics cost you money. So we want to be conscious. So when you enable, you may not see some of these, but we do allow you to configure and add more scraping rules so that you can get all the metrics that you need. Same for networking, right? ACNS is, Chandan was talking about it earlier, ACNS and flow logs directly integrates with Azure Monitor as well, so that really in Grafana, you can build complex dashboards to do your troubleshooting. We also have Container Insights, which collects your troubleshooting logs and has visualizations into monitoring health and performance of your Kubernetes cluster. It really complements your Prometheus and Grafana setup with an end-to-end Kubernetes monitoring across microservices and infrastructure. But any incident or disruption really starts with alerts, right? And NAKS provides native recommended alerts. And a lot of customers actually don't end up using it, and we want to change that. What are these? We've actually defined a set of alerts that we believe are essential for you to monitor your environment. For example, API server, utilization or node health pressure metrics. We have defined thresholds and alerts, and it's a one-click. You just enable them, and you get all of those in your Azure Monitor. And you can actually customize what happens when your alert triggers, right? You could trigger a troubleshooting runbook, or you could integrate with PagerDuty through webhooks. But why are we talking about all this? Isn't it always a DNS issue? So I want to have Sandhya over here to kind of talk about how do we help customers deal with those gnarly networking issues that they sometimes can run into. And over to Sandhya.
Thank you, Pavneet. Hi, everyone. I'm Sandhya Castellino. I'm a principal product manager in the Azure Container Networking team. I'm here to talk to you about how you troubleshoot networking issues. How many of you here, I'd like to see a show of hands, have run into a networking issue in production? Great. Isn't it always the network? DNS, yes. Anything else? NTP, anything else? Okay, so we heard you, and we specifically set out to make this product called Advanced Container Networking Services, which you've heard about from Chandan earlier, to simplify your networking troubleshooting. We want to give you deep visibility into the pod level metrics, pod level traffic data, show you your DNS errors to troubleshoot all of your DNS problems. TCP is another big one that we keep hearing from customers. TCP retransmissions, TCP errors. We show you all of that visibility, including your utilization at the pod level, in pre-built dashboards on Azure Managed Grafana that Pavneet was just talking about, or you can use your own dashboards. The way we do this is we use eBPF programs using agents from Retina or Cilium to generate this raw data, the metric data. We enrich that using Hubble, and then we send that data to either manage Prometheus and manage Grafana from Azure, or you can bring your own Prometheus and Grafana and view these metrics. But metrics is only part of the solution. What we're also doing is providing you deep debugging capability using Retina network flow logs. This is a new feature that we're coming out with soon, as Chandan mentioned in his keynote speech. What we do here is we provide you with user-defined filters. So, one of the top complaints we've heard about logs is, it drives up costs if you try to turn on logging. What we're doing to help you optimize on those costs is you enable this log generation capability using filters. And you can specify exactly what you want in those filters. Maybe you only want to see data for certain namespaces, certain pods, and then we generate the logs based on that filter that you created, and then you collect those logs either in Azure Monitor, or you can use an open telemetry collector or an external logging service and collect those logs. So I'm going to show you a demo on this new Retina network flow log capability. Okay, so what you have here is an AKS cluster, and the flow logging capability is turned off by default. So if you go into logs, you'll see there were no logs generated. This is just a pod, show your workloads, and it is integrated with Azure Monitor for this demo. We are applying a filter here where it's a CRD where you have filters from a certain namespace which is default to a namespace that is default. So you're only collecting logs between the default namespace. We apply the flow log CRD, and now when you go and check your logs, you have logs generated. Not only that, we have pre-built Azure Grafana dashboards where you get a connectivity graph based on those logs. It shows you all of your pod-to-pod connectivity. It shows you drops. It shows you DNS errors, which pods have the most DNS errors. And you can, when you go into the logs, we've separated out which are your error logs, if you only want to see the logs which have errors, or you can check all of the logs as well. If you have any more questions about flow logging or any of the metrics and observability capabilities, please reach out. We'd love to hear some of the other issues you've come across that we can help you provide observability for.
Thanks, Sandhya. So I've been told by Corey that we're running out of time, so I'm going to now speed through. Autoscaling. Now, every application is different, right? Some are CPU intensive that scale better horizontally. Some are memory intensive that need vertical scaling. And AKS really supports all of the above through managed add-ons. We recommend Kata because we believe it provides most extensibility in terms of autoscaling. And in particularly spiky workloads, you can use input metrics like ingress control HTTP requests to actually scale before your CPU memory spikes, right? So something for everything, really. And okay, my application is scaling, but oops, I forgot to scale my nodes. And I've seen this. I've seen customer support tickets where cluster autoscaler was not turned on or NAP was not turned on, but HPA was. So please use one of these two. Today, we recommend cluster autoscaler, which is the same upstream autoscaler. And the only reason that is because Node Auto Provisioner is not GA yet. It's going to GA soon, at which point we recommend that you take a look. It's based on the Carpenter project, and it really gives you a lot more flexibility in terms of SKUs, in terms of eviction policies, and faster scale down for cost optimization. Let's do a quick demo of Node Auto Provision. Is it running? Yeah. So here, what we are actually going to show is aggressive scale down. So we are going to apply a consolidation policy where if a node is either underutilized or empty, we want it to be scaled down, right? And we have a deployment YAML here where we have 8 replicas, right? I'm going to scale down this deployment to 4 and actually visualize how quickly NAP scales down the nodes as well. So here I have my 8 replicas. I'm just going to do a kubectl scale to reduce the replica count. Oh, that's the node claim. We have 2 node claims currently. And then once I scale down the deployment, you'll see that go down as well. I scale down the replicas to 4. And now that the replicas have scaled down, we have now nodes which are not being utilized, right? The utilization is dropped below a threshold. So we see the node is starting to scale down as well. And you'll see that the node claim has gone away as well. So that's how quickly NAP is responsive to scale downs. So it really comes in handy for your cost effective, where you want to be cost effective, that's where NAP really shines through. Yep, now we have just 1 node claim because the other one got scaled down by NAP. Cool. So what about network, right? We talked about a bunch of network features. Let's just do a quick recap. AKS recommends that our customers use overlay CNI networking for multiple reasons. It's the most scalable CNI in the Azure stack. It has better runtime performance, pod-to-pod communication throughput. So with the Cilium data plane, so that's what we recommend our customers to use. We have easy migration across CNIs. So if you're currently on KubeNet or Azure CNI, you can make a update call, and we will basically do a rolling restart of your nodes and move you to the overlay CNI. For ingress and egress, we today suggest standard load balancer. For inbound traffic, we suggest you use a backend pool type of node IP, predominantly because it gives you faster performance in terms of node scaling, in terms of creation of service. When you're creating a service at a large scale, that backend pool update happens much faster with node IP. And again, we have other options there. You have NAT gateway, and we'll go into some of that later into the presentation. Now, again, AKS offers multiple options for you ingress in terms of application networking, right? We recommend application routing add-on, which today uses Nginx. It works well for most web apps. It supports Ingress API today, and we are working on Gateway API support there as well. It integrates natively with both Kubernetes constructs and with Azure services, such as Key Vault for your certs and secret management. We also have application gateway for containers. Now, please note, this is different from AGIC. This is AGC. And it's a highly scalable and provides MTLS integration support as well. This one works well, particularly for your highly regulated secure applications where MTLS becomes a requirement. We're working on a managed add-on for this feature. And we're also working on WAF support. So at that point, once we have the managed add-on, it integrates with overlay CNI as well. So this is really maturing into a very strong offering in terms of ingress with Gateway and Ingress API. Now, let's talk about the things that worry most customers who are relatively new to Kubernetes, and see even some of the older ones, right? Upgrades. At a high level, you need to think about three things. You want to make sure you're catching the N-2 train and staying ahead and not going out of support. Ensure that there is no upgrade failure and keep high success rate. And then if upgrades succeed, there is no disruption to workload availability and minimize downtimes, right? That's the things that you care about. And the key points here are there are certain common patterns that we see, right, where customers have not configured their PDBs correctly. Actually, 70% of upgrade failures that we see are due to PDB failures. Breaking changes is really a thing of the past, because AKS actually checks for breaking change during pre-flight. So if you're using a API version in your cluster which is being deprecated from version A to B, we catch that and we catch that in the pre-checks and stop your upgrade. You want to ensure that you're setting, PDBs, requests and limits, your health checks, and your liveliness and readiness probes, so that you know when an application is facing disruptions. And really, we have a lot of managed features here. Justin talked about them, some of them in the keynote as well, that help you reduce the pain of upgrades. With node security patching, we've really made some changes based on feedback, based on past events, where we follow Microsoft Safe deployment practices, which means that every canonical Ubuntu image that is being rolled out has been thoroughly tested and is rolling out region by region in a safe deployment manner. It honors maintenance window. Based on if you've set maintenance windows, it honors those. And then you can also check the release tracker to understand what is the latest, where are the latest security patches, what is the current image that is rolling out, which regions has it rolled out to, among other such facts. We talked about this multiple times. Workload identity is our recommended way to manage permissions and authorization across different services that integrate with AKS. We have secret store integration with CSI driver that allows you to directly mount secrets, certificates, and keys directly into your pods. And then for policy management, AKS natively integrates with Azure Policy to enforce your built-in or custom security and governance controls into your AKS clusters. Now, let me hand over to Sachi, who's going to talk about how can you achieve more with AI on AKS.
Yeah, so when we talk about AI and Kubernetes, We're going to be talking about containerizing your AI, really managing your model artifacts throughout your AI pipeline, and promoting them throughout environments in a secure manner and also in an efficient manner. So yeah, we would want to containerize our AI model artifacts. So for different types of AI workloads, that ranges from inferencing, model serving, to tuning, meaning making your AI more context aware for your application user data, as well as training your models from the ground up. In Kubernetes, also, you'd want to deploy your AI in the same fashion as your other applications for integrating AI-specific features that are powering, let's say, recommendation systems or chatbots within your application. And we're going to talk about a project that we've been developing in open source called Kaido, which is the Kubernetes AI toolchain operator that has recently been accepted as a CNCF sandbox project for providing easy to configure out-of-box inference and tuning deployments, and expanding the scope very soon. And when running AI on Kubernetes, you have the governance of your data and model artifacts. So being able to maintain the data that you're working with, your models themselves, within your Kubernetes cluster. So how many of you folks have heard about Kaido or have tried it out? Okay. Decent number of hands. Yeah, so Kaido essentially simplifies the management and deployment of AI models in your Kubernetes cluster. So what does that mean? You start off with a Kaido workspace, which defines a range of different smart defaults for your workload deployment. And we also maintain a range of different preset model configurations, but it's not necessarily hidden away. You have the opportunity to look into the workspace custom resource definition and change these smart defaults based on what you're working with. So let's say the compute resources that you're looking to deploy onto, by default, Kaido will define some of the minimum GPU size, but if you'd like to change it to CPU resources as well, for having some cost effectiveness there, you'd be able to do so. So some updates that we have in Kaido are the developer experience in VS Code. So what does this look like? As a developer, you likely want to stay within your IDE and avoid all of the knobs that need to be turned in configuring your AKS cluster specifically for AI prototyping. So as an app developer, you're likely considering different models based on performance metrics and how it works in the context of your application. And doing so within Visual Studio Code is much easier now using Kaido. So you'd be able to browse the supported model presets within the Kaido model registry, deploy for inferencing workload in just a few clicks, and then experiment with different inputs, change the configurable parameters for the model, and then also have some more insights as to the inferencing runtime that you're running your model on. So I'm going to go into a quick demo of what this looks like. Okay, so starting off in the AKS VS Code extension, you can go and deploy a Kaido inferencing workload. So by clicking deploy an AI model and going into the Kaido page here, you can see what does the project overall look like, what is the overview, and essentially install the AKS managed add-on onto your cluster. And the managed add-on is currently in public preview. So after this page of clicking into Kaido, you can view all of the model presets that we have out of box. So these are a range of different model families that are highly performant based on the Hugging Face leaderboard. And you can go in, click on any of these different preset sizes, and essentially take a look at your workspace CRD. You can change the smart defaults, or you can just go ahead and apply it directly onto your cluster. And you can track the progress here, so your resources coming up, your inference deployment, and then what that endpoint will be like within your cluster. So it will then direct you to a model playground interface where you can submit different kinds of prompts. You can change the configurable parameters, such as temperature, top K, and adjust maybe what you're looking for in the creativity of your response. and see what that would look like when you go to integrate into your application. So from an app developer perspective, this is great for rapid prototyping, comparing the performance of models to start off, and seeing what that looks like on your existing or new AKS clusters. You can also take a look into your workspace log. So if you want to see how those GPU nodes have come up, whether the GPU provisioner part of the Kaido project has successfully deployed your nodes. And yeah, that's what that interface would look like. So in the next step of your AI journey, after experimenting with models and serving different models, then you likely want to make it more context aware. There is a point at which the performance will start to plateau if you don't have it tuned to your customer, your application specific data. So you have some options here. You can fine tune the model, and that could either mean retraining the entire model and changing all of those model weights that build up all of the layers, or you can use a parameter-efficient fine-tuning method, also known as PEFT, for tuning just specific layers of your model. And that is what Kaido implements for the fine-tuning feature within the managed add-on today. So that means that you can use less GPU compute in order to achieve this, while also making your model more context-aware and in a shorter amount of time on just a single node. So I'll show like kind of a diagram of what all the steps that Kaido automates along the way, and then how you can gain visibility into that deployment. But same with your Kaido workspace for inferencing, you would start off with a Kaido fine-tuning workspace. And this is an example of what that would look like. So this is essentially a custom resource. You have your fine-tuning workspace that defines what the job will be. You have a minimum instance type that you're deploying onto. So in this case, you can fine-tune the Phi-3 mini model on just a single A100 node in a reasonable amount of time as well. And you can choose between different methods of parameter-efficient fine-tuning. So there's quantized LoRa. I won't go into the technical differences between the two, but what your input would be for fine-tuning is the data source. So Kaido has some flexibility here. If you have a public data set that you're tuning based off of, or if you've already containerized your data, you have those two options to pull that in as the input. And then your output will very easily be a lightweight container image stored directly into your ACR. Because if you're working with proprietary data, sensitive data, you likely don't want to store that in a public image registry. If that goes straight to your private image, private ACR, then you have some governance over that data. So this is essentially what this workspace is creating on your behalf using the AI toolchain operator add-on. So you'll be pulling in your data, and that could be a container image. Then you have the base model image, and then your output will be a Docker image that's stored to your ACR. And a nice thing about this is that when you go and deploy new inferencing jobs, and you're leveraging your updated context-aware model, you can pull in different adapter outputs. And adapters are just essentially the result of various fine-tuning jobs on different types of data. So in your new inferencing deployments, you can pull in one adapter, you can pull in a range of different adapters, and then evaluate the performance accordingly. Just gonna skip this one. So another update that we have in Kaido is the upstream project, version 4.4 is now available in the managed add-on. So what are the updates there? In the default runtime for your inferencing workloads, now it will leverage VLLM and the range of different capabilities that VLLM offers, as well as Hugging Face transformers. So what does VLLM really offer for your inferencing deployments? Well, there's different Prometheus metrics that you have visibility into, and you can monitor your inferencing workloads at a more fine-grained level. And Kaido will expose them actually to the metrics endpoint. So you can pull that into Azure Managed Prometheus, Azure Managed Grafana, and have a lot more observability onto your Kaido inferencing deployments. VLM generally increases the serving throughput over 15-fold, and based on internal testing that we've done as well, on a single A100 node, this can be achieved in comparison to running your inferencing on Hugging Face transformers. So I'm going to demo what it would look like to monitor your inferencing workload with Kaido. So you can start off with one of the preset models that are deployed onto your cluster. So we're going to go ahead and describe the workspace, the Kaido inferencing workspace that's already been deployed. And we can see here, this is the Quinn DeepSeek model that's been deployed here. And what we have is that VLM is exposing Prometheus metrics, so range of different VLM inferencing metrics like time to first token and some other key performance evaluating metrics at the Kaido metrics endpoint. And we can see that the inference is ready, everything is up and running for our inferencing deployment. So what we're going to do is create a service monitor, and we're going to point that towards the Kaido metrics endpoint and pull that in using our AMA metrics pod in the Cube system namespace. So these within the Kaido upstream repository show all of the different metrics, what they relate to. So it could be your system stats, your performance metrics, and describe what the meaning of all these metrics are. And you're going to go into your Azure Monitor workspace and check that your service monitor is successfully pulling in the metrics. And what you can do just to test this out and check that everything is running as expected is go into the grid tab and type in one of the example metrics that you want to double click into. So you can see here that it's been scraping these metrics, and we set the default interval to be 30 seconds. And you can change that as well within the service monitor. And from here, you'd be able to go into your Azure Managed Grafana instance. And VLM actually manages a Grafana JSON like default template that you can use as a dashboard for any of these supported models. So you would go into your Grafana endpoint, and you can pull in that VLM Grafana dashboard and be able to visualize these metrics, track them over time, and use them to evaluate the performance of your inferencing deployment. Another great use case for these metrics is once you visualize them and understand what this looks like with your model deployment, you can pull them into horizontal pod autoscaler. So you can scale your inference pods based on one of these key metrics and use that accordingly to avoid GPU out-of-memory errors, for example, and scale out your inferencing deployments automatically. So in this case here, what we're going to do is take that default Grafana dashboard and specify our model name, and all of these key metrics will show up. Right now, we don't have any requests that are being sent to the inference server, but as soon as that starts up, then you can see all of the metrics over time. So as you continue along in your AI journey on AKS, there are likely some configurations that you want to make with regards to the GPUs that you're deploying onto, for example, and having some more fine-grained control over the usage, let's say, in order to optimize that resource-intensive workloads. So one feature that is currently rolling out and is going to be generally available soon is the skip GPU driver installation. So automatically today at GPU node pool create time, AKS installs the drivers that are specific to the GPU instance size that you're specifying. So that can be great for starting up with a certain NVIDIA GPU size on AKS today. However, if you want to use some tools like the NVIDIA GPU operator, for example, and all of the different configurations that it packages together, you'd likely want to skip the automatic installation on AKS and then use all of the components together that are offered in GPU operator. So this is a small but mighty feature that allows for that flexibility. And GPU operator can package together your drivers, your NVIDIA device plugin, let's say your DCGM exporter as well to export GPU specific metrics as well. So that is a capability that this feature offers that is releasing in GA. Another configuration that can be helpful for multi-tenant environments is multi-instance GPU. So it's a method of partitioning your GPUs into separate and secure GPU instances. And AKS has a managed feature for MIG. So each instance would have a dedicated portion of the cache, memory, bandwidth, and compute resources of a GPU. And you can run these workloads with predictable performance without interruption. And AKS offers different MIG profiles that you'd be able to apply when creating the MIG deployment. And you can divide an A100 instance, for example, up into 7 different individual GPU instances using MIG, as well as we have support for H100 MIG GPU today. Okay, so I'm going to pass it over to Pavneet to continuing to talk about optimizations.
Thanks, Sachi. So let's do a quick recap where we are in the journey, right? So with Ahmed, we got from a app that was written on a flight to production in Kubernetes with Automatic, and then we did some deep dive into what are the basic operations around upgrades, auto scaling, observability, and then we were able to add more intelligence and fine tuning of the AI that was running to kind of using Kato to be able to customize my application and the AI powering it. Now let's go a little deeper into the optimization part. So we hear from almost every customer, right, that once they're on a platform and they're kind of stabilized and matured, they want to optimize and get the most out of it, build efficiency into the system. Now this can mean control over the features such as better performance, or they want observability, extensibility, or having more complex networking requirements, right? And AKS really enables all of those use cases. Again, starting with the control plane. While AKS control plane is a fully managed provision component for you, the performance that you can get out of it is a bit of a shared responsibility. And why do I say that? The reason I say that is because more and more we see users are running open source, third-party controllers and clients in their clusters, and not all of them are optimized to be a good kube client citizen, right? I've seen cases where an upstream component can practically DDoS an API server, right? And while we may be able to protect the API server from keeling over, you can still have severe performance degradation or scale shrinkage. So we are actually investing heavily, and there's some best practices there that I would love for you to take a picture of that you should follow in your operators or controllers that you're writing. But we're actually working heavily on making this even easier for you so that your side of the responsibility becomes less and less. We're working on up to 4x the current control plane scale that will basically allow it to be DDoSed more heavily. But we're also working on better throttling, right? How can we throttle certain clients that are behaving badly as bad citizens more aggressively so that we can protect everything else in the cluster, right? We are also backporting some of the performance features from latter Kubernetes versions like 1.32 and 1.33 into AKS supported versions so that no matter where you are, you get those benefits. Another slide for the cameras. Similarly, we have been optimizing the AKS defaults in Portal and the API layer so that you can get the best performance, both in terms of node provisioning, but also in terms of the runtime on the node, right? For example, one of the things that I still see is customers end up deploying production workloads on free tier. That's not what it's meant for. We highly recommend using standard or the next generation tiers like Automatic or premium. We want you to use the latest generation VM SKUs. They are better in terms of node provisioning latency. They are better in terms of cost efficiency, in terms of runtime performance. So, V4, V5, V6 SKUs is where you want to be. We want to make sure that your system pools are of the similar or corresponding, not similar, of corresponding size to your cluster. For example, you should enable auto scaling on your system pools. You should use 8 or even bigger core VMs if your cluster is scaling to hundreds of or thousands of nodes. Use ephemeral OS disks so that you get both faster node provisioning, but also better IOPS performance on the node itself. Now, it's all great. You've enabled auto scaling. You've enabled, you're using the right configurations to get the most out of it. But you still have certain requirements around resiliency, around disaster recovery, right? So there are 3 options that AKS provides today, or 3 patterns that we see customers use. Customers can deploy their node pools with like different zonal configurations, right? You have zone spanning, zone aligned, or regional. Zone spanning is the easiest. When a pod goes pending, we trigger a scale request to VMSS, and they scale with the best effort spreading. Best effort spreading being the keyword. So if you want hard, alignment across different zones, you want equal spread, you're better off with the zone aligns, where you have one node pool in each zone, and you're scaling them independently. And that's our recommendations as well. If you're using cluster autoscaler, we highly recommend that you use zone align rather than zone spanning. Regional, if you're running a dev test cluster or don't have high availability requirements, you can use regional where one or all of your nodes can be the same zone. But for production, please don't. Now switching gears a bit, right? What about the storage? You're using, let's say, zone aligned. You're spreading your nodes. You're spreading your application across your zones. What if I have similar storage requirements, right? And really, there are 2 use cases here. One is your stateless workload, where your application is basically doing the replication of data in the app layer. And there you can use LRS disks, which are zone pinned essentially. So the responsibility of making sure that the data is being replicated is on the application layer, right? So if a zone goes down, the application can handle that even if one pod gets evicted. But if you have stateful workloads, right, which is very common now with workloads like Kafka or where Zookeeper, where you have leader elections, and you want to make sure that you are able to handle zone outages or zonal, in case of Spot, you're able to handle evictions. We highly recommend using zonally replicated storage or ZRS disks, where the storage layer handles the replication of data. So you don't need to worry about it in the application layer. AKS natively integrates with a host of storage options. We provide 2 modes of using those different storage options. One is Azure Container Storage, which integrates with disks, Elastic SAN, local disk, Azure disks, right? And that basically provides a storage pool as an overlay in your cluster, and you're using claims to basically get storage capacity out of that pool. And then we obviously also support CSI drivers, which is what mostly native Kubernetes upstream and most vanilla flavors of Kubernetes use. CSI drivers not just integrates with disks, it also integrates with file storage. So if you have cases where multiple replicas are reading and writing from a same file store, that's where you can use the CSI driver for Azure File to use that with AKS. Now let's move up in the layer, right? What can you do in the application layer so that you make sure that you're setting it up for good resiliency? Well, set pod disruption budgets. I can't emphasize this enough. Pod disruption budget is basically Kubernetes native concept, which makes sure that at least n number of pods remain running, and n being the pod disruption budget. And that really assures in case of Spot, if you're using Spot, or if you have any sort of outage, or if you're doing an upgrade and we rolling restart your nodes, you want to make sure that the minimum number of replicas stay available through that change event. For resource-intensive applications, you can pin, and you should pin those applications to specific nodes using taint and tolerations. Use multiple replicas, and you can use topology spread constraints to control how you are kind of spreading your pods across the different nodes and different flavors of nodes that you might have across your node pools in a cluster. Now, another area where customers can really optimize performance outside of your cluster autoscaler profile or using the right VM configurations is really at the image pull time. Especially for AI workloads, those are really heavy images, right? We have two features that really improve the performance of image pulls. One is artifact streaming, which you need to enable. It is not enabled by default, and it's currently in public preview, which basically lazy loads the images onto the node so that your containers can actually start before the whole image has been pulled and extracted, right? So that can reduce up to 15 to 20% in terms of your node image pull time. And the other feature is actually default enabled starting Kubernetes version 1.31 in AKS, which is parallel image pull, where we're not pulling your container images sequentially, we're pulling them parallelly. So think of burst scenarios where you're provisioning a new node and a bunch of pods get scheduled on it. Now that's a lot of container images being pulled. If they're pulled in parallel, it's going to be faster, and hence you get better container startup time. Keep in mind, there is still a bottleneck there, which is the OS disk layer, right? If you are using a low performance tier disk, or if you're not using ephemeral OS disks, that constraint will remain for the image extraction. That's why using ephemeral OS disks makes that faster, not just at the node boot time, but also for the containers to start up. Now, I was discussing resiliency with best practices with a customer yesterday in a meeting, and this came up, right? Which is, no matter what you do, it's not a placement for load testing or fault testing, right? There is so much drift in your system. As it matures, as things change, configuration changes, you might add new components to your stack, which may not be zonal resilient or may have other points of failures or do not scale automatically. So it's very important that you're running regular load tests, right? You're running regular fault tests. And AKS makes it very easy for you. With Chaos Studio's integration with AKS, you can actually simulate spot evictions. So for example, if you want to understand, hey, can my application handle spot evictions? Can I replace that with new capacity, for example, with Node Auto Provision? You can actually simulate that with Chaos Studios. You can also simulate AZ outages. So you want to bring down a zone, you can simulate that and then see, hey, all the best practices that Pavneet told you at KubeCon, were they actually working, right? Put that to test. Now, the associated part to testing is monitoring, right? So let's have Ganga over here to kind of help talk about how do I monitor my application layer, right?
Thank you, Pavneet. Myself is Ganga. I'm an engineering lead in Azure Observability team. My team primarily work on Azure Kubernetes, Prometheus, and Container Insights. So here I'm going to talk about very interesting feature, auto instrumentation with application insights. What this feature does is literally without any code change, you can go from zero visibility to the full visibility. And this feature today is in public preview. We support Java and Node.js containerized applications. You can deploy at namespace level or a deployment level. So just enabling this feature without modifying any code, you can get full feature set of the application insights like live metrics and application map and troubleshooting and monitoring, alert, pretty much all the features literally without any code change. So I'm going to talk about the unified experience which Austin mentioned about. So this unified experience, we pretty much pull all the signals across the stack from the cluster and the from container insights, logs and events, and networking. Also the VMSS load balancer. Also, as part of this experience, what we did is we improved this experience to once we have our application insights integrated with auto instrumentation, you can get the insights of your applications. As you can see here, you can just look at application performance metrics right in that experience. You can navigate to the application and look at, let's say in this case, Java applications having performance issues. You can just navigate to the application sites blade and click on troubleshooting. You can then, if you look at this call stack, end-to-end call stack, it will give what exactly happening. In this case, my Java application is failing with the home kill. So yeah, you can get complete end-to-end experience without any code change to our containers applications. So here I'm going to talk about the configuration part of the auto instrumentation. So the auto instrument is like either you can use existing application insights resource, or you can create a new one. Then you just take the application insight connection string and put into the Kubernetes CR. Then once you do that, you can get the application map. Here I'm talking about the application map for this Contoso Air application. And here in this case, I'm seeing high latency between the backend here. Just I can drill onto the high latency part and see what's exactly happening here. So other aspects I also want to talk about. We did the few enhancement to observability stack, the multi-tenant logging feature, which Austin mentioned here. So multi-tenant logging feature will enable, if you're running a shared cluster, you can segregate the logs by different Kubernetes namespace to different log analytics workspace. Like say you are running a shared cluster, large shared cluster platform, and you want to give a full control to the application developer to view the logs and control the cost of the logs. Also, the infrastructure team can configure their logs going to the infrastructure log analytics workspace. And this feature also can be used to control the cost. You can configure, say, the verbose logs to the cheaper SKU, such as basic logs SKU, and the critical logs you can configure to analytics for dashboarding, alerting, so you can bring down the cost. And the other feature is about the CRD support for Azure Managed Prometheus. So this feature primarily, we are taking exactly the OSS schema, and you can configure and enable at your namespace level using service and pod monitors. And this also has support for the pre-built integrations. And other aspect about is diagnosis settings, like control plane logs. Either you can use the Azure Analytics log analytics workspace, or you can use the cheaper storage options such as storage account, event hub. So the cluster optimization aspects, we have a rich workbook. This provide the rich capability about detecting liveness probe failures in terms of the frequency, how frequently they are happening. Also identify the event anomalies. Let's say you have application where you see there is an image pull error because of some network policy is preventing to pull the image. You can look at that broad issues happening across the cluster, not specific to one particular container's applications. Another aspect is the optimized container limits and requests. So this Grafana dashboard will give a different views. It will identify the containers which it doesn't have a limits, so you can act on it. Also, you also figure out from historical data what are the right limits to configure. So you can look at this dashboard and figure out whether there is an opportunity for you to set the right limits and requests. Also, if there is an opportunity, like say if you have a container, some application developer deploy the containers application without limits and requests, that can cause noise and neighbor issues. Those are also surfaced as part of this Grafana dashboard. And from logs, the cost is the main concern. We are keep working on improving the cost. We have few options, but we are continuously improving with bringing the cost down for the logs. So one of the feature, we have a basic logs. This cost is minimal compared to the default analytics queue, and you can enable the lot of verbose logs to basic logs to bring your cost down. Also, with Azure Managed Prometheus, we're recommending our customer to use metrics in the metrics store, Azure Managed Prometheus. So we only ingest the logs to the Azure Log Analytics work so that you can bring down the cost. Also, we have various filters at using ingestion transformation, also through DCRs. And to avoid any surprises, you can also configure the daily cap at Log Analytics workspace. And that also is provided as part of the recommended alert. I'll give back to Pavnit.
Thanks, Ganga. So we looked at some of the optimizations or customizations Azure Monitor Stack provides with AKS. Now let's continue that theme of cost saving, right? How do you get to a point where you can understand where you're spending money on AKS or Azure, and then how do I get to a point where I can actually start optimizing it, right? And Justin touched upon this in his keynote, where we have the new AKS cost recommendation feature, which identifies what are the opportunities for cost savings and how can you optimize that within the cluster, from workload right sizing to understanding auto scaling tuning that you should be doing, SKU selection, right? If you're using a underutilized, larger SKU, it will give you a recommendation to right size the SKU as well. And then for deep dives to understand, like if you're running a multi-tenant cluster, right, where you have multiple application owners in the same cluster, which is probably true for most of you, AKS cost analysis gives you a granular view into the infra cost and breaks it down at your Kubernetes constructs, right, your namespaces, your deployments, so that you can understand who's spending the money, how, and where. So let's say now you found out, okay, application A is spending a lot of money. It's not a production application. It's an internal or a dev test or a non-critical applications. Maybe I should be running it on Spot, right? But Spot can be tricky. But so how do I get to a point where I can guarantee or get as close to possible as a guarantee of compute availability with Spot? And that's where node auto provisioning really shines, right? You can use Spot strategies with node auto provisioning, which offers basically a compelling optimization on cost. By defining eviction policies and applying stronger weights to Spot VMs, you're basically saying that, hey, whenever Spot is available, give me a Spot VM. But if Spot is not available, still scale up, but use a on-demand VM. And that way, you're almost getting as close to possible of a guarantee of a compute availability. You can actually save up to 80% cost with Spot and node auto provisioning. So we highly recommend the node auto provisioning is in preview today. Check it out. It's going GA soon, and it's a really powerful tool. So we talked about scaling, observability. Let's go back into the security mode, right? With AKS, how do I make sure that my API server and my communication to API server is secure? And really, there are 2-3 options there. A lot of customers we see use public clusters, which means that their node pools are talking to the API server over the internet. And that's not really what we recommend. We recommend that customers use private clusters or API VNet integration with public clusters, so that the clients and all the things running on your node are talking to your API server over a secure private endpoint, which is the case in private cluster, or we use API server VNet integration, where the API server itself is injected into your VNet. That way, the traffic between the nodes and the API server stays within your private network and never leaves or goes through the internet. API server VNet integration is in preview today. It is going GA soon. So keep an eye on that. I see people smiling when they heard GA soon. So continuing on the network theme, we talked about load balancer as a recommended option and the default option in AKS. But some customers need to use custom firewalls, right? They need to use custom firewall rules or they want complex traffic routing. So for that, we enable user-defined routing, where you can basically control the whole end-to-end flow of your network to your cluster. You can use third-party firewalls, set up Azure firewall rules, and really control how your ingress is happening in the cluster and the nodes. Now, the next big question that comes up quite often is, how do I decide which CNI to use? So let me call back Sandhya over so that she can talk to you about pod networking options and continue that theme into CNI and container networking.
Thanks, Pavneet. Okay, so we have different options available for you to connect your pods to other resources or services and also allocate IP addresses to the pods. Which option you pick is going to depend on what what kind of connectivity you want for your pods. The number one question to ask is, do your pods need direct IP connectivity from externally from the cluster? So either inbound or outbound, maybe you have a mesh setup where your pods need to be accessible from outside the cluster. If they don't need external connectivity, we recommend that you use the overlay model. And with overlay, you can easily scale across clusters. You don't need a dedicated IP address space. You can reuse your IP space from one cluster to another. We also support dual stack for overlay. It's fairly simple. If you do need external connectivity, you have two VNet IP options available to you. With pod subnet, you have a dedicated subnet that you can use to address your pod IP, your pod IPs. There's either a dynamic allocation that you could use for efficiency, but if you want to get to high scale, so one thing I wanted to mention with overlay, you would pick overlay if you also want high scale. We support up to 1 million IP addresses for your pods with overlay. You can also get that with the direct IP VNet IP option with pod subnet if you use static blocks. Otherwise, you're limited to 65K IPs for the pod IPs. If you want simplicity and you still want external connectivity, you would use node subnet. You do give up some flexibility here because you have to pre-allocate the IPs for your pod, so you have to design that in advance. But if it's very simple and easy to use. And if your cluster size is small, there's a 65K IP limit, it works well. You might be wondering why KubeNet is not on here. Yes, some of you, I can see reactions across the room. That's because we've just announced deprecation of KubeNet. And we are recommending that you go to one of these options, but on the Cilium data plane. Now, why are we recommending the Cilium data plane? The first reason is because of high scale and performance with Cilium. What do I mean by that? Let's take the example of one of your IP tables data planes like Azure NPM today. If you use Azure NPM, you're limited by scale to 250 nodes and 15K pods. On Cilium, as Chandan announced earlier today, we support 3K nodes and 150K pods with network policies applied. And without network policies, that number goes even higher. Cilium also gives you a policy enforcement engine. And so all of the ACNS features that I will talk about coming up next all require the Cilium data plane because that's what we use for policy enforcement. But on the on the plus side, you get all of these extra advanced policies that you can set up. You can set up DNS policies, L7 policies as well with ACNS. Cilium supports all of the data planes now, all of the CNI options that I mentioned. Node subnet has just gone GA as well on Cilium. So you can migrate from KubeNet to any of these options on Cilium. What about NPM? Many of our customers are still using NPM. We are going to be announcing deprecation of Azure NPM later this year. So we are recommending, because of all the investments that we're making in Cilium, that you move to the Cilium data plane, especially if you're on Linux. If you're on Windows, you can go to Calico for now until we get Cilium support on Windows.
So I saw some fist bumps when we said KubeNet is being deprecated. But what if I'm in KubeNet or if I'm using NPM? What do I need to do?
If you're using KubeNet, we have migration steps in place for you to go to Cilium. Depending on which model for the CNI you want to pick, it's either a one-step or a two-step process to get there. So that's been published in our public documentations already. For NPM, similarly, we will have migration options and some solutions for you, some recommendations for you to get to Cilium. With policies, it's much trickier for us to just provide a blanket recommendation because we do not know which policies you have specifically applied in every network, but we will have some guides and some guidelines for you to move to Cilium as well. Great question, Pavneet. If this slide looks familiar, it's because we covered ACNS for network observability, but Advanced Container Networking Services also gives you advanced security, so it's a 2-for-1. Who doesn't love that? With network security, in addition to all of the observability capability I talked to you about earlier, what we have is FQDN filtering. We give you advanced security filtering capabilities, starting with DNS filtering. We will have L7 network policies as well, and encryption coming soon with WireGuard. With DNS network policies, this feature is already GA, by the way, so you can try it out. We heard that setting policies using IPs is hard because IPs keep changing. You can now use FQDNs to set up your DNS policies and make them more resilient. This, as I mentioned before, you will need the Cilium data plane for any of the security capabilities, which is why we're recommending you all upgrade to Cilium. I'm going to call on Vamsi to talk about L7 policies.
Thank you, Sandhya. Hi, I'm Vamsi. I'm engineering lead in container networking. So I just want to go a little bit deeper into network policies, right? What Pavneet has been saying is, okay, day 2 operations is about securing, optimizing, and continuing. So in the same sense, it is very important for you guys to secure your workloads. Obviously, L4 network policies, amazing, right? And DNS solves the problem of like churning through IP addresses. And L7 takes it a little bit further, going into even HTTP, Kafka, and your gRPC rules, right? So here there is a simple example we have where the HTTP rules can be applied on method, your headers, your path. So that gives you a little bit more flexibility into how you can secure your applications. With that, also we are coming up with transparent encryption very soon. This will be with Azure managed keys. So once you turn it on, you do not have to worry about it. Underneath platform will take care of encryption between node to node, and your applications are like running as if there's nothing done to them, right? So let's go into a demo of L7 now. So with Cilium, when you deploy it and when you enable ACNS, you will see that there is an ACNS security agent deployed. That has both standalone DNS proxy in it, and coming soon you will have the L7 proxy in it, which will handle your policies, right? So this is a simple example. We have a client and a server, and the client is talking on 3 paths, a/A, and a/B. Now, we are applying the Cilium network policy, which is trying to restrict what the client can talk to only the root path, right? So that is just, we are trying to, very simple also, the policy just transcends the existing L4 network policy Kubernetes design language, right? And then it adds in the additional data, which is your rules for HTTP or Kafka, etc. So we should have sped up the demo a bit, but anyway. So now you can see that, hey, we are applying a rule for / on port 80. And then once we apply this rule, we will see that immediately the server is going to send a 403 for other parts, but only is going to allow the slash path. So it is very simple that way, and you could see that the /A and a /B are getting 403s, and slash is being allowed to the server, right? And it's not just that. And so providing this is good, but at times what happens is we do not know if it is being applied properly. So that's why bringing in observability is even more critical for us. And you could see with Cilium and Hubble, we can see all the traffic which is being with dimensions of, hey, this request is getting this response code, and this is the metrics you are getting. And then we also have these integrated into managed Grafana dashboard. So it is even more accessible for us, for you guys to see how it is performing. So this is the new dashboard. So if you are familiar with managed Prometheus, managed Grafana, and ACNS, we have Kubernetes networking path. So in that, we have until now DNS workflows, and now we are coming up with this new L7 dashboard built into managed Grafana, which gives all these capabilities into the managed experience. So with that, I'm going to give back to Pavneet.
Thanks, Vamsi. So I've again been told we are going over time, so I'm going to speed up again. Apologies. So staying with the theme of security, we talked about network security, we talked about control plane, but you get the end-to-end holistic coverage, right, with AKS, from your secure supply chain with your container and node images, to control plane, to securing the node with patches, deeper into the networking stack and in the application stack. You get that end-to-end security through a variety of features. So you might want to take a picture of this slide. And we took it a step further, right? We've heard from customers, especially in some financial services sector, where they want their cluster to be air-gapped almost, right? Network isolated. And that's something that we currently, it's generally available with outbound type none, and we're working to support other outbound types as well, where really we have locked down the cluster where it doesn't even have access to the MCR repositories anymore, and you get a pretty much an air-gapped cluster in AKS. But what if somebody does get through? When a malicious component or actor does get through, you can actually lock down specific parts within your node as well. With seccomp default, you can actually restrict syscalls by setting the seccomp default provided in your kubelet configuration, establish an extra layer of protection against common system calls, vulnerabilities exploited by malicious actors. Similarly, we have the IMDS restriction, where a non-host component cannot talk to the IMDS service and get infra metadata about your Azure resources. Talking about secure supply chain, we have a bunch of features, starting with the public preview Azure Linux 3, where we're really looking at what is the least amount of components we need to run in a Linux version, so that we can provide you with the container OS and AKS. We've upgraded several of the components to higher versions, like run C, containerd, and kernel upgrade as well to 5.15. Then you have the Azure Container Registry features that, again, Justin talked about in the keynote, where, for example, the Azure Container Registry continuous patching, which takes away the pain of patching the image and pushing it again to the ACR, and now it can all happen in the ACR layer itself, where if a patch is available for a specific component or a specific layer in your image, we can directly do that in ACR itself. Now, I'm going to call Maya from Defender Cloud team to kind of talk about how does Microsoft Defender for Cloud help you in your AKS environments and secure end-to-end.
Thank you. So, hi again. So Microsoft Defender for Cloud actually provides like 3 different layers of security. And now with the development of AI and the fast, rapid deployment we see, security becomes more important than before. So Defender for Cloud starts all the way to the left in the CI/CD pipeline, supporting different CI/CD pipelines, scanning and providing tools for posture across the development cycle. Then moving on to posture management, we see that Defender for Cloud can provide risk assessments and view of the hygiene of the environment, prioritizing based on context and risk, and providing tools to customers to fix their security hygiene early on. And closing the loop, the third item in the cycle is monitoring your runtime environment for post-breach and attacks and providing tools to monitor that. Oh, sorry, I actually wanted to skip that slide, but so I wanted to show to you today like how Defender for Cloud actually monitoring the entire development lifecycle across the entire SDLC. So providing tools from code to CI/CD pipeline across different CI/CD pipeline, whether it is GitHub, GitLab, and all and every tool you might be using, and then enabling our customers to actually be proactive and prevent the pipeline from moving forward by gating builds. Then we monitor the container registry. Again, different registries. Of course, we support ACR, but also the different registries out there. Then providing admission controller and gating capabilities based on vulnerability results to either deny or approve each deployment. Then in runtime, there are capabilities also to monitor compliance and for threat protection with drift and response action to mitigate existing threats. Finishing up by reminding the new exciting features we have announced just earlier this morning with AKS, starting with agentless runtime vulnerability assessment, which is agnostic to whatever registries you're currently using. Kubernetes host features that provide tools for you to know which are your part of the shared responsibility model. And of course, guardrails and putting gating rules on top of your Kubernetes deployment signed by Microsoft, scanned by Microsoft, and wrapping it all up in a concise experience within AKS portal, providing you just like the information you need to make sure your clusters are secured. So if you want to see some cool demos, because we're short on time, I have like dedicated sessions for that in the AKS booth on tomorrow and on Friday, so meet you there. Thank you.
Thanks, Maya. So we're in the home stretch now. Your application and your environment is secure. Now you want to standardize, and for that, I'm going to call up Justin back to kind of talk us through those features.
Thank you, mate. So, Contoso Air, they've done pretty well. They've got their VC funding. They're opening up operations in Asia, and so they're going to now spin up not just their US operations, but also in Japan as well. And so now you need to start thinking about, how do I do that? So it's a standard kind of environment would be that you'd have multiple AKS clusters, multiple Azure Container Registries, or synchronizing those container images in multiple regions. And then you need to start thinking about, how do I actually then push traffic to those different regions as well. So you can either use kind of Traffic Manager or Front Door to be able to do that. It's a relatively standard architecture on Azure to be able to do that. But something that we say quite a lot in the AKS team is that if you have more than one stage or more than one cluster, you probably should be maintaining those with Fleet. And this is really where the standardization comes from, right? Your operational standardization. how do I do upgrades? How do I roll out my applications? And we discussed some of the features that allows you to be able to do that at global scale. And so Fleet is really, really important part of that, to be able to manage those clusters, manage them globally, and to be able to provide that level of standardization. I think everyone on the AKS team can agree with me, which is like, if you have more than one cluster, more than one stage, you should be using Fleet. It's as simple as that. Okay, and finally, we're going to finish off. This is cool.
Yeah, so remember the app that was deployed early on, and Contoso used the automated deployments to generate the Kubernetes manifests. Now that they're more seasoned in Kubernetes, they actually want to come up with their own templates, and they want their developers to standardize on the way that they want the applications to be deployed. So if you've not heard of the Kubernetes Resource Orchestrator, it's a new operator for Kubernetes that really simplifies the way they can create complex resources. And on Azure, we also have the Azure Service Operator that can help you deploy and maintain a variety of Azure resources using Kubernetes constructs. So things like SQL databases, caches, and more. So if you combine both of these concepts together, you can actually have a very powerful way where you can templatize an application and its Kubernetes resources and its Azure resources in a way that can help your developers really focus on the app itself. And I have a really short demo here for how you can combine both of these together. So the way this works is KRO has something called the resource graph definition, where you define a new custom resource definition of what an app is. You have a schema with a bunch of parameters, and then within there, you actually define the resources that you want to deploy. So your deployments, your services, ingresses, pod disruption budgets, and basically anything that you need to deploy in that cluster. Once you create that resource on the cluster and apply it, your developers are now able to use that to deploy their own apps. So here I'm creating a web app, and within that I'm just specifying the subdomain that I want to use, the image that I want to use, and the container port. So I'm deploying two different web apps here. And by applying those Kubernetes resources, the application and its components will be deployed shortly. So what you see here is that because I'm using Azure Service Operator, I'm actually deploying a resource group for each of these applications. I could have also deployed a bunch of other Azure resources in there. So you see there's the deployment, the ingresses, and all the stuff that you need. And just like that, the app and its components are now published. So just head over to the booth and we can talk about that and even more during the roundtables.
Good save. Thank you very much, everyone. Please scan the QR code and take part in the survey.